Find the curve's unit tangent vector and the length of the indicated portion of the curve. We have the function right here. We have the portion right here. Begin by finding the unit tangent vector. Recall that the unit tangent formula is the derivative of the function over the magnitude of its derivative. So to find r prime t, derivative of ti is 1 plus derivative of 2 over 3 t 3 over 2 is, multiply these two numbers together, you get 1 t. Subtract 1 from this value, you get 1/2. Okay, don't forget to write your components. Now, next step, you can rewrite this as 1i plus square root of tk, and now it makes it easier for you to find the magnitude, which is square root of the value squared plus t squared. Okay, so you end up with 1 plus t, because any number times t is squared, and 1 squared is 1. Okay, now you will now plug these two values into this equation. So 1i over square root of 1 plus t is your first component, plus square root of tk over 1 plus t is your second component. So this will be equal to t. So this is the unit tangent vector of this function. Moving on, find the length of the indicated portion of the curve. To find the lengths, you could do arc length. Use this formula of arc length is equal to integral of b to a times the magnitude of the velocity, which is r prime t. So we solved for r prime t early on because it's right over here. All you need to do now is to plug it into this integral and recall that the portion is here. So this would be the b value, this would be the a value. So b is 15, a is 0, and then the magnitude of the velocity, which is r prime t, is square root of 1 plus t, okay, dt. Now, all you need to do is you need to integrate this, and because there's a square root, you could rewrite this integral to be 1 plus t 1/2 dt. Okay, now we are going to use substitution so that we could integrate this. So let's make u 1 over t. Okay, du will then be 1 dt. Okay, isolate dt, you get dt equals 1 du. Okay, now let's remove this portion. Okay, so this is what we have now. We have 15, 0, okay? We have u over 1/2 power times dt is 1 du, so du, okay? Now you can integrate this. So 1 over 2 plus 1, 1 over 2 plus 1 is 3 over 2. So you will then have u over 3 over 2, okay, over 1 over 2 plus 1, which is 3 over 2 du, okay, move that. Okay, so when you divide by a fraction, it's the same thing as multiplying by its reciprocal. So u 3 over 2 is the same thing, over 3 over 2 is the same thing as multiplying by 2 over 3. So you then have 2 over 3 u 3 over 2, okay, du. Now, move this part. We then have 15 to 0, 2 over 3u, 3 over 2 du. Next step, substitute back u into the integral. So we substitute back we have 2 over 3 times 1 plus t, 3 over 2 dt. Okay? Now, all we need to do is to substitute 15. We don't need the integral sign because we already integrated. So, my bad, it should be this, okay? Substitute 15 into t. You then have, let's erase this. You have 2 over 3, 1 plus 15, 3 over 2, okay? Now, we minus substitute 0 into t. So, if we do that, erase this. You have 2 over 3, 1 plus 0, 3 over 2, okay? And you plug that into a calculator. 2 over 3 times 1 plus 15, 3 over 2, minus all of that. So make sure you do all of that minus 2 over 3 times 1, 3 over 2. You have 42. So the arc length, which is the length of the indicated portion of the curve, is 42 units. There you go. You have the unit tangent vector and then you have the arc length.